Next we have the density of the unit cell. The density of a unit cell which indirectly tells us about the density of the solid. That means if I wanted to know the density of any particular solid, then instead of then we calculate the density of the unit cell, and the density of unit cell is nothing but the density of the solid. Now how to calculate the density of a unit cell? So simply for calculating a density we have a formula that density is equal to mass upon volume. That is, it's a unit cell, so I can say the mass of unit cell upon the mass of volume. The volume of unit cell. The mass of unit cell. The mass of unit cell, now in this case the mass volume, once I said the volume of unit cell, generally it is a cube. So being a cube, the volume of a unit cell is going to be a side cube. If it is some other type of unit cell, sometime in exam they ask some different type of density of the some other type of unit cell. So if there's some other type of unit cell, then instead of a cube I will say it's a into b into c, where a, b, c are the edges. But here since we are considering the cubic cell, so A, B and C all are same. So A into B into C, instead I can say A into A, that is the volume of unit cell is A cube. And then mass of unit cell, the next. Mass of a unit cell. The unit cell is an imaginary diagram which we just draw to know the arrangement of a particle. So mass of a unit cell, the unit cell doesn't have its own mass. Then unit cell mass depends upon how unit cell we get by drawing those particles and all. And as I said, unit cell is an imaginary diagram. So being imaginary, it doesn't have its own mass. Hence, I can say that the mass of unit cell is nothing but the mass of those particles which are present in a unit cell. So mass of unit cell is nothing but the mass of, or it is equal to the number of particles. It depends upon the mass of those particles which are present in unit cell. So number of particles in a unit cell into mass of one particle. Number of particle in a unit cell, I am representing it by small letter z into mass of one particle. How to know the mass of one particle? Mass of one particle, that is one atom, one molecule or one ion. So it is equal to the molar mass upon Avogadro's number. Why I'm using this formula? A simple reason behind it we have. Suppose I wanted to know the mass of one carbon atom. Mass of one carbon atom means I can say I will consider 1 mole carbon. 1 mole carbon which contains 6.022 into 10 raised to 23 carbon atom. And the 1 mole carbon, the mass is equal to 12 gram. So I can say that the mass of 6.022 into 10 raised to 23 carbon atom is equal to 12 gram. So what will be the mass of one carbon atom? Then mass of one carbon atom will be equal to nothing but 12 upon 6.022 into 10 raised to 23. What is 12? Then simply I will say 12 is the atomic mass of a carbon. And this is Avogadro number. If it is an atom, then atomic mass. If it is a molecule, then molar mass. So molar mass upon Avogadro's number. So it's a Z into molar mass is capital M upon Avogadro's number, that is Na. Now let us substitute in the formula of a density of unit cell. We have M into Z, the mass of unit cell, that is, this is the mass of unit cell, M upon Na into Z upon volume of unit cell. As I said, volume of unit cell is nothing but A cube. So here I can write the formula I got, M into Z upon Na into A cube. So this is the formula which we use for calculating the density of a unit cell. So if the numerical is asked from this chapter, then for density we will have this formula, where M stands for molar mass, Na is the Avogadro number, Z is a number of particle in a unit cell. If it is a simple unit cell, Z will be 1. If it is a body centered, Z will be 2. If it is a face centered, then Z will be 4. And A stand for edge length and A cube stand for the volume of a cube or the volume of a unit cell. Simply for remembering a formula, we have a term, this term we use MAZA, that is maza. Now in the case of this, just keep in mind M stands for molar mass, MAZA, that is maza, and this A is nothing but Avogadro number, and this last A is having a cube. So ultimately we will have a formula for the density, that is maza. So for calculating density, we use this formula where that is, so instead of using this formula directly, mass upon unit cell upon the volume of unit cell, if the question is asked from the solid state, then for density you have to use this formula in while solving MCQs.